address fused into it, but it will take whatever MAC address you put into the firmware file. If you put a certain content into the firmware file, I think it triggers the loading of its built-in MAC address, and I think we didn't do that. And I thought we'd fixed it so we didn't have to try to. Anyway, what it's doing if it does that little toggle thing is it's reading MAC addresses off of the processor chip and using a variant of those to put them in the Wi-Fi chip. So it's getting MAC addresses from the processor. Since the Ethernet is not actually used on the processor, we could just use the Ethernet MAC addresses for the Wi-Fi.
Okay.
Because we're never actually going to use the MAC addresses for Ethernet because the Ethernet's not on here.
Right.
So we grab those off the Ethernet and put them on the Wi-Fi through the firmware file.
Okay.
A little bit of deep inside baseball here, I guess. What else is stopping us from getting to the fact that the board's just up and running for everybody with the new image? Yours is powered off. That's going to keep it from working.
Yeah, I'm just waiting to reflash that specific image because we couldn't get that Beaglebone to boot from the SD, but we have the other one that booted from.
Okay, but you have the other one up and running from
Yeah.
from SD. Okay.
Our EduMip is booted off of whatever image it already had. It won't properly
Boot off of micro SD.
with the new Edge.
Yeah. So we'll debug that in a bit.
But
Because
then-
we're going to try to put a micro SD card in and see if it can read it. And first thing we're going to do is try to see what's actually on it. Or are you powering up that EduMip too?
Yeah, so EduMip is booted and doing some activity just with its, or whatever image it had.
Okay.
Then this Beagle from our class.
Is
classroom,
flashing now, or?
It's flashing from, no, it finished flashing and powered down, and now we just powered it back up.
Okay.
Sorry, what'd you do? Oh, it powered down and then you
Powered down.
remove the SD card and power back.
So if I look at the Wi-Fi now, I should probably be covered in Beaglebones, right? So each one of these should come up with a different SSID. What I find to be really, really helpful is to write on a sticker and stick it on the board what its magic SSID is, so that I can connect to it repeatedly. You'll notice a number of these have numbers written on them. Even when you flash it again, right? The algorithm we use to essentially compute what the SSID should stay the same. So they will all still be unique and they will all come back with the same one even after they've been reflashed. Right? Unless we change that little routine that we use to come up with the SSID based on the MAC address, because it's just the last 4 characters off the MAC address. Anyway, so you can safely stick that on the board and connect to it next time. So we'll connect up to the one that we want right there, and you use this magic URL. So the question.
If I don't have the sticker that says this is my last 4 MAC address, I was able to get onto it through the USB using the.
How do you find what it is?
Yeah, but I could go to the ifconfig or whatever to.
Exactly. So if I look at this, I hit Control B and a square open brackets now because I want to scroll back. So if we look at this soft AP0, this one is CE8E. Right, so this board, if I look at the Wi-Fi, CE8E.
I'm looking for the CEA on your.
It's in 2 places. It's in the iNet 6.
Okay, so
It's also in the Ether.
Okay.
So that's the MAC address. It's the last four characters of the MAC address.
And what did you type in the command prompt to scroll?
ifconfig. Oh, to scroll, I hit Control B and then square open brackets. What's running inside of this Linux terminal is a tool called tmux. tmux is this way to share a terminal session and save terminal session state between computers. So I can actually have multiple computers logged into the same terminal session. I can disconnect and reconnect to it without it losing its history and other things. It's a pretty cool tool for Linux shells. Some of you haven't seen, who has not seen this IDE before? So I think a number of people haven't seen this IDE. Just you guys?
If you never
You've
used
seen
the
this
Beaglebone,
IDE?
when did you use Cloud9?
What's this ID?
Ah, okay. What is this IDE?
What is do you know what an IDE stands for?
I don't know what's the full form of that, but it's like Atom or like.
Yeah, so integrated development environment.
Yeah.
So this one is called Cloud9. Is this made by Amazon?
It was purchased by Amazon.
But you made it.
No. I wish, right? I wish I could get to cash in off of that one. No, it's there was a startup. I don't know what other names they went by other than Cloud9. They took the ACE editor, which I think ended up being from like Mozilla ended up maintaining that, which is there's a long history of open source stuff, but Cloud9 was essentially purchased by Amazon. Our relationship with them goes back before that. Yeah, I don't know if I have any great other descriptions. So it's an open source project. It's written in JavaScript and Node.js. So it's a Node.js based IDE. It's being served by your board. We're not using the cloud. The cloud's the board, right? So there is no external service. It's not. The only thing it's relying on is your web browser and a server that's running on the board. Sorry, slides say Pocket Beagle, but yeah. It's got 3 main windows or 3 main areas on it. There's this, whatever you have in this tab over here. So you'll have like the workspace, which has the list of files. You can, I don't know what navigate commands really do. I've never even paid attention to them. I do pay attention to this changes thing, and in future software images, we're going to start populating this better. But this is actually the IDE's integration to Git, G-I-T. And that is a version control tool. It's the one that's used to maintain the Linux kernel. It's the one that we use to maintain all of our source code. So getting familiar with Git is really nice. In the future, the example library will be available. The history on that example library will be available here. It changes.
You opened up. Did you?
So right now it's under the examples folder. So it gives me a history of the different files. So I clicked on this left side. So by default it should be workspace. So there's kind of 3 main windows. Really 2 types, right? This left-hand side, which is controlled by this tab over here, and then this tab view on the right-hand side, which you'll typically see broken into this 2 spaces, but they're really the same type of window. There's different tabs up here where we do our text editor, but a special type of tab, which you can start up by clicking this plus, is a terminal, right? And that's the Linux command prompt, right? So this is where we do our live interaction with the board, right? By default, you'll see, this welcome screen here at the top, and if you double click any of the files on there, it'll open up a text editor where you can edit those files. It doesn't auto-save when you click run, by the way. You have to make sure you hit Control S or Command S to save the files. I feel like I'm losing folks a little bit, so I need to try to figure out how to make this a little more interactive. But at the bottom, you'll typically see the Linux command prompt. This is also where you'll typically see the run windows. Like if you click run on one of the programs up here, it'll open up a runner down at the bottom. we'll explore the run window in a bit. These files are kind of, these are going to change between different images, the sets of examples. Those all live in the file system at this location called var lib cloud9. How many of you have used the Linux command prompt on a regular basis? You're familiar with it? How many of you just used it at all? Nobody's not used it, right? So you'll see username at hostname :path. This is running a tool called bash. Is the command line interpreter, and so there we can issue commands. The most helpful thing on the Beaglebone Blue are these RC _ commands. So the way a command line is structured is the first word you type in is the name of an executable program. So write a compiled application, it's an ELF file that you want to run. So that's the first word. And then any spaces after that and other words become what are called arguments. So in your C, if you who's written a C program? Good. Even if you do most of your stuff in Python, the same things kind of carry forward. In a C program, you have int argc, which is your count of arguments, and argv, which is the pointer to the strings of those arguments. So all of those other words become different arguments, and there's strings for those arguments. So the program then decides what to do with those arguments. So
The
that's
RC
something.
program will decide what to do with your next.
Like if I say RC version, there's a good one. RC version, that's the name of a program, and press enter. The RC _ version program, if it's in my path and it finds it, will execute, and then it has access to the terminal for standard input and output, and it writes to the standard output, which is my terminal.
So you gave no arguments, and this is the default.
Correct. It doesn't seem to pay attention to any arguments, but if I wanted to tell this program additional information, I could put a space and I could write other words after that.
What if you give it garbage after that?
I don't think this particular program, that's all program dependent. So it depends on the individual program. If this program is ignoring the arguments, it doesn't do anything with it.
So
now there are some special things that are interpreted by bash itself. So there are certain symbols, or there's also certain what's called built-in commands. Help is a built-in command. That's not actually running a program called help. It's what's called a built-in command, where it says that the bash interpreter, which is the program that's running here.
Oh, that's
So that bash interpreter, if it knows that word, instead of running that program, hey Dr. Morgan, it will just run that built-in command rather than an executable program. And so if you type in help, it actually lists off what the built-in commands are. There we go. So we can actually see what those different CPs, some of these, I don't know if they're anyway. So some of the magical things that you'll do a lot of are what's redirecting standard input and output.
Where's the student, the capstone students? I feel like a few of them said they were coming.
So LS, very, very helpful program. It lists the contents of a directory. There's all sorts of places where you could find lists of these different Linux built-in or Linux programs, not just the built-in ones. But sysclass LEDs is a place where all the LEDs show up in the system. And so you see this listing of the files. SysFS is a virtual file system. It's not these aren't files sitting on a disk, not in the file system. They are dynamically created by the kernel. So this is the way the kernel generally exposes access to hardware, is through files. In Linux, everything is a file. So if you understand the idea of working with files in any programming language, you can start programming in Linux. Right.
So everything is a file as opposed to what?
As opposed to an API, right? That's the other, like if you were doing a lot of RTOS stuff or programming in other types of environments, like Arduino, right? With Arduino, you would typically, I have the magical API of, who's programmed Arduino? Because I think most people